Okay, welcome. So in this lesson today, we will be looking at the responses of the CV system in regards to exercise. We will also take a look at the adaptations in this video. So make sure you're making notes on those. So we will understand the responses and adaptations, explain the science and how we can create a revision resource, and also analyse the adaptations in regards to exam questions. Just to recap then, are definitions for responses and adaptations. So responses are those immediate effects. They don't last long, and when you stop exercising, those responses stop, those effects stop. Our long-term changes are known as adaptations, and that's a result of training, and these are long-lasting. Okay, so when you stop exercising, you still have these changes that have occurred to your body. Short-term responses then, starting from the top. We have written in our last lesson all the responses down, and now we'll look into further detail. So we have anticipatory rise, and that's an increase in heart rate just before exercise, and that's caused by the release of adrenaline into the blood, and that sympathetic system speeding the heart rate up. That also links to that increase in heart rate. So during exercise, in order to deliver more oxygen and remove carbon dioxide, we increase our heart rate. The sympathetic system increases our heart rate to deliver more oxygen. Okay. So short-term responses, increase in cardiac output, that's our third response, okay, the amount of blood leaving the heart per minute. And we know our calculation for cardiac output is Q equals heart rate times stroke volume, or you could say the opposite way round, stroke volume times heart rate. It doesn't matter which way round, you should still return the same mathematical answer. Okay, so that increase in cardiac output means there's more blood leaving the heart per minute, which obviously is helpful because it means we're transporting more oxygen and getting rid of more waste products at a faster rate. Okay, then we've got our fourth response, the increase in stroke volume, so the amount of blood leaving the heart per beat. Okay, again, if we've got either stroke volume or heart rate is increased, that in turn increases our cardiac output. Okay. Another short-term response is our increased blood pressure, and that's during exercise. Blood flows at a faster rate due to that increased heart rate. Therefore, the heart is also contracting more forcibly to squeeze more blood out, and that will cause an increase in systolic blood pressure. So our normal blood pressure would be 120 over 80, a high blood pressure would 140 over 90, and a low blood pressure, otherwise known as hypotension, would be 90 over 60. So you might see higher figures like you can see on the monitor, maybe 140 over 90, just slightly raised when we're responding to exercise. So again, this is another short-term response. This is our last one now, so last one of 6 responses, and that's the redirection of blood flow. So the response is that during exercise, more blood is needed for energy production. Therefore, we redirect that blood to areas that need it more, and that's done through the process of vascular shunt, essentially. So that's achieved through vasodilation, supplying active areas with more blood, okay, those working muscles, and vasoconstriction, supplying inactive areas, okay. So that's that vital organs and digestive system. Okay, so our long-term adaptations now, there are 7 of these, so this is 3 of them. We've got cardiac hypertrophy, and that's when the muscle will grow in size as a result of training, and that's the thickness of the left ventricle will increase, allowing the heart to contract more with greater force. Okay, we get an increased stroke volume, and that's the amount of blood pumped out the heart per beat, which will increase as hypertrophy happens. And stroke volume is increased at rest during exercise as well, which means our cardiac output is greater. So decreased resting heart rate, that's when stroke volume is increased. The heart does not need to beat as often as at rest to achieve the cardiac output required. So therefore our resting heart rate will decrease. Okay, so decreased heart rate recovery time. Obviously, the fitter you get, the more likely you are to be able to recover quicker. Okay, so your heart rate remains elevated after exercise to aid recovery, but with a higher stroke volume, that heart rate can return to resting sooner. The fifth one, capillarization, so that's that development of the capillary network. So it means that they're more dense in the muscle and the alveoli, and that allows for greater gaseous exchange because there's more contact time with the lungs, so we can offload that to the muscles. So more oxygen can be supplied. We can get rid of the waste products, which helps with your VO2 max, which is that oxygen consumption. Okay, so we can consume more oxygen when we're exercising. And reduction in blood pressure, that resting blood pressure. So blood pressure is reduced at rest, and that reduces any risk of any heart-related health. Finally, then, our last adaptation is an increase in blood volume and hemoglobin content. So blood volume is the amount of plasma and red blood cells circulating around the body, and training can increase that count of plasma and the red blood cells. Okay, so this will help with oxygen delivery, temperature regulation, and as the volume of plasma increases, a greater extent of red blood cells, the viscosity of the blood may decrease. Okay, so that will just result in resting blood pressure decreasing a little bit. Okay, so that is obviously helpful because we're obviously still transporting oxygen to our working muscles. Okay, now that we have watched the video, see if you can answer these questions, double check your answers, and just have a think. Are you rock solid? Do you need to reread or do you need to revise? So it'd be worth having a go at this exam question, pause the video, have a go, and then mark your answer based on the mark scheme.